Hello, this time we're going to go over a problem about consistency. So in this case, for which values of k is the system below consistent, meaning having a solution? And to start with that, let's do the following. Let's transform this into its equivalent matrix augmented form. So I'll collect the unknowns, x, y, z in columns, along with the constants to the right of these equations. So I have 4, 12, negative 2, 4, negative 16, negative 5, negative 7, k, 5, 7, 20, negative 2, right? And then from this point, what we're going to do is proceed with a series of reductions that will make the system readily, much more easier to read, right? To read its solutions, if there's any. Okay, so let's do the following. First operation that I'm going to perform, I'm not going to follow the standard procedure, but as long as I'm following row reductions, valid row reductions, I'll get an equivalent system, right? So to row 2, I subtract 3 times row number 1. Thus, I will obtain the following system, well, the following matrix. 4, 4, negative 7, 7, 0, negative 28, k plus 21, negative 1. And then the third row remains untouched, so negative 2, negative 5, 5, and negative 2. Then, from this operation, I'll do the next one. To row number 3, I add 1/2 of row number 1, and I will get the following matrix. 4, 4, negative 7, 0, negative 28, k plus 21, 0, negative 3, 3/2, and then on the constant columns I have 7, negative 1, and 3/2 as well. You can verify those computations. Next, well, what I'm going to do is perform this operation. So I have to row number 2, I add 28 of row number 3, and I will obtain the following. 4, 4, negative 7, 0, 0, k plus 7, 0, 1, negative 1/2. Oh, before I do that, small correction here. Let me do the following operation beforehand. So let's do this. Negative 1/3 of row number 3 to make it more manageable. So we have 4, 4, negative 7, 0, negative 28, k plus 21, 0, 1, negative 1/2, negative 1/2, negative 1, and 7. And then from here, we do the following operation. We're going to get rid of this. We're going to use this as a pivot. And we obtain the following. To row number 2, we add 28 times row number 3. And we get this. 4, 4, negative 7, 7, 0, 0, k plus 7, 0, 1, negative 1/2, negative 15, negative 1/2. And then we pause for a second here. You say, look, at this point, we can do the following. We can take this as a pivot, this one, and eliminate this 4, right? We can even turn this into a pivot, right, by multiplying this row by 1/4. But really, the crux of the matter lies here. The only thing that is in our way of continuing with the process is whether this entity is 0 or not. If it's 0, the system is inconsistent. Why? You may say, why is this? Well, look, you'll have something that looks like this in terms of an equation. 0 times x plus 0 times y plus 0 times z, right, is equal to negative 15, which is impossible. This is false, right? That's not the case. 0 is not negative 15. But this says that, well, if k plus 7 is not 0, what would happen? Well, look, we can transform the matrix that we have here into this. 1, something here, something here, and something here. And since this is different from 0, we can multiply by its reciprocal. So we will get something that looks like this. 0, 0, 1, and then who knows what. But then this one looks like this. 0, 1, 1/2 negative, negative 1/2. And then from this point we can proceed, because we can use this to eliminate that one. And now the system will look like this. 1, 0, however we do it, then something else here, who knows what that's going to be, something else here, who knows what that's going to be, 0, 0, 1, and then who knows what is here. And then we have 0, 1, negative 1/2, negative 1/2. But then at this point, look, I may use this as a pivot to eliminate these two. And at the end, I will obtain something that looks like this. 1, 0, 0, who knows what, 0, 1, 0, 0, 1, who knows what, and then 0, 1, 0, by eliminating this with this one, and then who knows what here. That's not important. I don't really care what the solution is. What I care is that there is a solution. That's it. So that's the condition that I'm looking for. The system has a solution, aka it is consistent if and only if k plus 7 is different from 0. Well, so as long as k is different from negative 7. And with this we finish. Thank you.